Geeks for Geeks has a challenge for you, the 390 challenge. Choose what you want to learn in 2024 and aim to complete at least 90% of the course in the next 90 days. And if you do that, you get back 90% of what you paid for the course. We believe you can do that. Now all you got to do is commit to your success, commit with Geeks for Geeks.
Hi, and welcome to Geeks for Geeks. I'm Siddhartha Hazra, and today we would be doing the post-contest analysis of Geeks for Geeks Weekly Coding Contest 154. So before I move forward, just give me a quick one if my audio and all is everything fine enough or not. क्या sir late करा दिए? No, absolutely not. I just like my Wi-Fi was not up to the mark, so I thought that why not restart it before the stream itself? So I got 2 minutes late itself. Okay, fair enough. So if you ask me the feedback of today's contest, this contest was comparatively on a very constructive side, but I think that the last problem, which is arranging horses, was not that up to the mark. Like it was a pretty too much straightforward, if you ask me itself. It was a pretty straightforward, so they could have like tweaked the question a bit if you just asked me about the review. Okay, fair enough. So else all the questions today was on the good enough side. Okay, so let's see the very first problem, which is check if okay, so we need to check if there exists another string that is an anagram of a string. Okay, if there exists another string. Okay, fair enough. We need to build another string, which is an anagram. Okay, but by the way, they shouldn't have given us the second test case, if you ask me. So now today, there I want, but I couldn't solve. Solve problem is indeed very interesting. I would tell you why. Like once you solve a problem of that pattern, like you can solve all the other problems. Okay, so like let me share the screen. And that's where we come to the entire screen. And let's have this layout option. Okay, so now see. Okay, so here we are told that given a string, okay, we are given a string and we need to find another string which is an anagram of this string. Like let's say we have A, B. So what are the other strings we can have? And what do you mean by anagram? The frequency of each character should be same at the other string. So we can have something like BA using the same constituents, and BA, which is a different string than AB, is also an anagram of this. Okay, now see. The thing is, let's say what the question meant us to do is, like let's say we have A, B, C. So let's say I have a person, like there are multiple students in a class, and the name of the students are A, B, A, C, D, A. Okay. Now, what they want is they want like as a teacher wants to shuffle the class, and after shuffling, no one should be at its previous position. Let's say if there is A, I can't have A here if you ask me. Okay, so like there should be one difference out of everything. Okay, like ऐसा नहीं हो सकता मतलब I need to shuffle it. Okay, see let's say there are students A, B, A, C, D, A. Okay, once what happened was the principal came to around in my classroom and he told me that Siddharth, I want you to shuffle the classroom. And he would tell me that the shuffle, like the shuffling is considered to be successful if at least one person is not in his previous position. Like if I am able to change the position of even one person, that is also considered as a successful shuffling. Let's, for example, to understand this, let's say that I shuffle this person and this person, and though both this person are same, so if I shuffle this, it would be same. So this is not considered as a correct shuffling. But if I shuffle A and B, then see B here, A here, and rest everyone remains the same. And this is also considered as a successful shuffling. Why? Because these two positions are different than the previous position. Like the simple example is like after shuffling, at least one element should change. After shuffling, at least one element should change. Same goes for this question that we need to basically see if a shuffling is possible for this question or not. Okay. So I can see by this second example only that see every time the shuffling would be possible. Why? Because what can be done is even if there are two characters like A and B. So I can shuffle A, B, and here it would be B, and here it would be A, and here it would be A. So this is the correct shuffling. Okay. So we can always be able to shuffle, but we can't shuffle when we have one character only. Now, if I shuffle this to this, the characters would still be the same. Now, if I shuffle this and this, the characters would still be the same. Why? Because if everyone is same, like if everyone is same, there is no point in switching places. I would be in my previous position. Like there would be no difference after shuffling or before shuffling. So this observation that if there is only one kind of value, shuffling is not our solution. That is why we can say that this is not possible. So what we basically need to do is we can conclude that if we have two kind of elements, then we can always shuffle. So the answer is no, only when unique elements like unique characters are one. Unique character count, unique character count is equal to 1. Else it would always be a yes. Do I make sense? With that example of shuffling, don't take the example of anagram because I think so that you won't be able to comprehend it till that extent. But if you just keep the idea of shuffling, which you have been hearing for an entire span of school and college, then it makes more sense. Do I make sense to you? Just give me a quick one and then we can move forward to the solution of this problem. Just give me a quick 1 or 0. So Zor problem was interesting, but I couldn't solve it. Okay. I got to the fourth, but I was confused with the order. Yes, to be honest, the problem statement was a confusing thing. Okay, fair enough. Now let's move forward to the solution of this problem. Check anagram. So what we basically do is, so we need to count all the unique characters. So we can simply insert all of them inside a set of characters only, and we can just insert the value of j. And at the end, if that is the solution, it would give me a correct solution. Now, for a person who doesn't wants to use set, can use an array of size 26. Okay, and then he can just iterate over the array for int e of a and then a of e minus a, that is we just subtract 26 from there and we add it. Next we can just check if the value is how many values have count greater than 1. So if the values of count greater than 1 is more than 1, we reply no. Else it is equal to 1, we reply yes. Just the other way around. No, I messed up again. So this is the solution. So I would give you my solution. Yep. So this is the most fastest one that I can proceed and just implement and move forward. Generated the URL. Okay. I have solved using one character. Yes, there are many solutions to this. See, the mindset in a contest should be that not to get the most optimized one, but to just surpass the AC. I said, whenever you give the contest, just keep that in mind that there is no extra points for optimization. Like let's say you took this, let's say you took 5 minutes to implement this approach, and I quickly just did it using set to count unique values. I did it in 2 minutes. Even though your solution is more optimized, I would be ranked ahead of you. Okay, that is why the mindset should be different in terms of contest. But still, these kind of solutions are respected a lot in interviews. Okay, so let's move on to the very next question. What was the next question? Let me see. That is minimize the distance. Good one. Again, a lot of jargon and all needs to be told. But still, let me just tell you how I would comprehend this problem statement. So see, today I think so the explanation would end early. I think so. Okay. See, bacha. At this point, see, it is told that the horse, has n houses. Okay, and each is located at a specific position x of I. Okay, now it is told like this. Let me explain you what this question wants to tell you. So it is kind of like I bought a land on, like, let's say this is a strip of land. Let's say this is a strip of land. Okay, and let's say this is what this is. Let's say the first 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Let's take a very simple scenario and understand this. Okay. See, bacha, let's say I am doing farming and this is a strip of land and there are 12 blocks of land where we can do the irrigation. Okay. Fair enough. Now, let's say I bought, I am the owner of this property, I am the owner of this property, I am the owner of this property, and I am the owner of this property. Then, let's say I am the owner of this property. Okay. So now see, let's do this also. So now I want to have a scarecrow which would have a minimum distance to everyone. I want to set up, let's say I am doing a irrigation at each of these blocks of land, and I want to set up a scarecrow which would have minimum distance to everyone. So now even though you don't use programming much and think in general, the scarecrow should be placed in between. Why? The scarecrow should be placed in between. Why? Then only it would have the minimum distance to everyone else out there. If I just place the scarecrow in just very between of all the strips of land over here. So in this question also it is told the same, that they want to set up a grocery store on the street that minimizes the sum of distances between the houses. So either you can read and comprehend this, or either you can understand this through this example that I have a strip of land and I am the owner of these all lands and I want to set up a scarecrow which would have minimum distance to all the irrigation land. So the best position where the scarecrow should be placed is in the middle. Okay, is in the middle. So if I talk about a set of numbers. So now if I give you, let's say that I am the owner, instead of this visualization, if I just say you that I am the owner of 5, 2, 10, 8, and 12. So now what will you do to know the middle position? So you would simply first sort it so that you get the median of it. So after sorting, this would be something like this, that 8, 10, and 12. And then you would place in the very middle of it. So just this visualization that we need to place a scarecrow in the very middle of the sorted strips is what? So here you are given the location. So the idea is that you sort the location first and then place the scarecrow in the very middle. To be honest, you don't really need that much programming idea, just the idea that placing it in the middle. So placing it in the middle in mathematics is what? The median value, mean, median, mode. These are the three values we can think of. So median works the best here. So this is what we would do. We would first sort all the values. Then we would just say that the middle element is the best possible answer. Don't overcomplicate it by thinking in terms of data structures and algorithms. Okay, just think of a strip of land where you need to place a scarecrow and just it's a common thing that if we place a scarecrow in very between, we would get the air. So if you don't really understand the example of the scarecrow, I am a person who is from Jharkhand, so irrigation and all is common in my area. But let's say you are not from a part where irrigation and all is common. So I would tell you one more example of this. Like when do we say that, let's say let's say this is me and my other cousin sisters and my sister, like all my brothers and sister, cousin and all, they all came at my house. Now, let's say there is a pedestrian fan. I don't know how many of you know this. Let's say there is a pedestrian fan which is giving the air to everyone. Or let's say there is a cooler at this point. Let's say there is a cooler at this point. So now what happens? Let's say we all cousins are fighting and we all are sitting in a sofa like this and we are watching TV. So to get equal amount of air to everyone, my father came and told us that keep the cooler in between and start the swing mode so that everyone would get equal amount of air. Make sense? We do this in real life. Same goes for this also. We need to find the optimal distance where everyone would get equal opportunity. So we would do that minimum distance from everyone. So we would do that. Same enough. So the idea is comparatively on the simpler side. What we would do is we would simply sort the array. We would take out the middle value. We would take out the middle value. Okay. And then we would return what is in the middle. Okay. Now a small question is that why is this n minus 1 divided by 2 is done? So this is a trick that people do in programming. If you are a person like from C++ or Java, you should know this trick. That if I want, like let's say if I want the seal value and if I want the floor value. So one is that you use the seal method or floor method to implement this. But most of the time they are not that much stable because sometimes they give double values, sometimes they get integer values. So to combat this, what people do is to have a floor value. Let's say I want the floor value of 5 divided by 2. So what I would do is I would simply subtract 1 from it. Okay, so formula to get sorry, the formula to get the floor value is n minus 1 divided by 2. Just assign it to an integer. Here to get the seal value, it is n plus 1 divided by 2. Just learn this because you would see a lot in programming. So now see, if I want to get the floor value, let's see if we can get the floor value or not. See, 5 minus 1 divided by 2 would give me 2. But here if I do 5 plus 1 divided by 2, it would give me the seal value. So people use these two formulas to get the floor and the seal values basically. Even if you see here, like let's say 4 minus 1 divided by 2, okay, floor value, okay, 4 minus 1 divided by 2 would give me the floor value. Here it would give me the seal value. Okay, fair enough. I think so. This was a small thing that is not frequent with beginners. So this was a small thing. So let us go back. So this is a small bit of code. I would just copy this and send you this. Give me a quick one if you have understood the solution. Or do I need to explain more over this problem? Just give me a quick 1 or 0 here. Okay. Wasted 4 minutes in B by returning cost instead of the X coordinate. Damn. For the second, I thought that we can choose any number in the and we have to choose only the number given in the array. Yep. First can be done by using two pointer from starting pointer character otherwise. Okay. Yep, you can do it. I was stuck on average for so long. Why median, not average, is applicable here? So see, yep. This question is very much important. Why? Average is not applicable here. Let me explain you that why average is not applicable. So let's say why average is not applicable here. So let's say I implement average over here, and let's, for example, I don't want to calculate the average as of now. Let's say the average turned out to be 9. Let's say the average turned out to be 9. Okay. So now if you observe that everyone is paying a cost for that. 9 to 10, the cost would be 1. 9 to 12, the distance is 3. 9 to 8, the distance is 1. 9 to 5, the distance is 4. 9 to 2, the distance is again 7. So now see, everyone is paying a cost over here. This example is not the most accurate one because if we take 8, the value would be added in 10. Okay, this side. But I'm just trying to explain you. See, everyone is paying some cost. So we can suppress the cost of just this element by implementing a scarecrow from here, because what we want the sum of distance to be minimized. So why not keep here so that from here the distance contributed would be 0. That is why instead of average we are taking down to median. Translating the same in Hindi for simple and better understanding is I would explain you a small thing. देखो, the idea is कि अगर हम average लेंगे, okay, so the average might be a position which is not void, okay, or not something which is already present. So now everyone would be paying some cost. So why not keep it on a bought land so that for that particular land the cost would be 0. That is why average is not working. Did I make sense to you, Neil Knight? In your example, averages makes more sense. Yes, I understand that if you give here the value becomes 0 contributed by 8, but for 10 the value is still 2. So for this side the average won't work. The average would work, sorry. But for other example, average won't work. Okay. Atulya, Ankit, can you tell me? Average can soar high if you have something like this. Got it. Thank you. Okay, let's move forward then. I think I'm good enough. What is the next question? Zorging. It is the most like elegant question that I have came in a while in Geeks for Geeks. Even though this is an easy problem, but trust me, I had a lot of fun solving this because I have seen of the problem before. Okay, I have seen up this problem in, I think so, in my ICPC rounds. I would tell you the round also. Like one day I was giving a mock, like I was solving previous problems of ICPC back in my school days. So, not school, sorry, back in my college days. And then in a previous year question paper of ICPC, I saw this problem. By the way, this is a common problem. So let me tell you what this is all about and how to draw the solution. See, bacha, is my screen is visible? Anshul, Neelkara, I think you can wait a bit and let me move forward and go into the third question and then tell you that please don't spam Akash Arora and Anshul. I don't want to break the flow. Sorry if I sounded too blunt at this point. Okay, so see, here in this question, it tells us that find all the number of pairs who have this value. Okay, what is this value? A or of B is should be equal to A XOR of B. Okay. Now let us see who all respects this property. So if I have one or one, and if I have one XOR one, is it equal? One or one is equals to one, but one XOR one is equals to zero. So this is not equal. Then let us see one or with zero and one XOR with zero. So now I can see 1 or 0 is equals to 1 and 1 XOR 0 is also equals to 1. So this is true. So plus 1. Okay, now let us move forward. Like let us say 0, 1 and like as as this is a common property of all the operators. That is the common property of all the operators is 1, 0 or with 1. So let me tell you that A XOR B is equal to B XOR A. And same goes for A or B is equals to B or A. So here just remember all this. So now here also if you observe the value is equal. So we have a plus 1 to our answer. Okay. Now let us see if we have 0 0 or not. So 0 0 or with 0, is it equal to 0 or 0 or 0? Yes, 0 or 0 is equals to 0 and 0 or 0 is also equals to 0. So again a plus 1 to our answer. Okay, makes sense. So now see, a element is made up of bits. An element is made up of bits. So let's take the example of what is this value? It is said that uh, A and B should be less than 2 to the power x, and that value is 3. Okay, so 2 to the power x, x is equals to 1, 2 to the power 1. So now see, let's take a big value that let's say for example, x is equal to 2. X is equal to 2. So 2 to the power 2, like less, it should be less. So we need to find all the values which are less, which are equal to less than equal to 3. Okay, we need to find all pairs of A and B which is less than equal to 3 or less than 2 to the power 2. It is given here. So now see, just for instance, and that would make more sense. So see, if I talk about 3, it is made up of what? 2 bits, that is, Okay, it is made up of 2 bits. So now if you observe that I can keep here 1, I can have 3 possible combinations here. I can keep here 1 0, and I can also keep here, I can also keep here 0 0, and I can also keep here 0 1. Same goes for this position of bit also, 1 0 0 0 and 0 1. Okay, like at each position, 3 possible combinations can be present. At each position, 3 possible combination is present. Three possible combinations can be done. Is it true? Just give me a quick 0 or 1. Just give me a quick 0 or 1. Sir, zeros or 0 is equal to 0. Yes, that's what I'm saying. That 0 or 0 is equal to zeros or 0. So both are equal to 0. So we have 3 equations where they both would satisfy. Just give me a quick 0 or 1. Is this true or not? Okay. Now see, bacha. If let's say at a particular position, 3 possible combinations can be done. So let's say I know that let's say if the question asks me that find all the values less than equal to 2 to the power, let's say 5. If let's say the question is asking me find all the values which are less than equal to 2 to the power 5. So I know that less than 2 to the power 5, or let's say let's take a very small value, 2 to the power 3. So less than 2 to the power 3 means what? 7. So 7 is what? 4 plus 3. So that means that I am allowed to keep anything, in the first 3 bits. I can keep anything here and that value would be less than 2 to the power 3. But if I keep anything here, like if I just add here, let's say if I make everything as 1, then this value is greater than 10 to the power 2 to the power 3. How? This is this is 2 to the power 4 minus 1. That is 15, I think so. That would be 15. This value should be 15. So if the asked value is 2 to the power 3, then in 3 bits, I can keep here anything. Like I have the allowance of 3 bits and I can keep here anything. Because in 7, we have all the 3 bits filled. So if I can keep here anything, I know, I know that three possible combination, 3 possible combination from the first bit, 3 possible combination from the second bit, 3 possible combination from the third bit. I can say that. So if the value asked is less than 2 to the power 3, it is none other than 3 multiplied by 3 multiplied by 3, which is equal to 3 cube. Now let us see again. So let's say if we are asked less than equal to the power 4, then we have the allowance of how many bits? 1, 2, 3, 4. And we can have 3 possible combination from the first bit, 3 possible combination from the third bit, 3 possible combination from all of the bit. And this is equal to 3 multiplied by 3 multiplied by 3 multiplied by 3. This is equal to permutation. This is permutation. The number of different permutations we can have. So this is none other than 3 raised to the power 4. So now we can say that whatever is asked, that is 2 to the power x, we just need to compute. And this idea of that in each position, I can have 3 possible combination, and in each bits, it is just the permutation of that. That is where it is becoming a bit of constructive problem. Here you don't need that much maths. You need to play with bits always. Okay, so you don't really need that much idea of algorithms, data structure algorithms. A good amount of playing with bits is good enough. So now the problem is to compute 3 raised to the power x modulo mod. And if you observe, the value of x can be huge. The value of x can be huge. 10 to the power 5. Value of x can be very huge, 10 to the power 5. So here you can directly multiply at each step and implement mod. How you can implement mod? You can use up this formula that that what you can do is like the formula of a multiplied by b modulo m tells us that we need a modulo m multiplied by b modulo m and then whole modulo m. The formula tells us this. So if let's say we are told to compute the value of 3 raised to the power 4, what we can do is 3 multiplied by 3 whole modulo m, that is whatever the value is given, and then again 3 raised to the power 3 and then whole modulo m, and implement this formula to this. You can do this directly because it is 10 to the power 5 and it would give you the answer. But if you want to do this efficiently, I I urge you that you should learn the concept of fast exponentiation. Fast exponentiation. What is this fast exponentiation, Siddharth? Fast exponentiation, Siddharth? So see, if let's say we are told to calculate the value of 3 raised to the power 10, then we would be multiplying 3 10 times and the number of operations are 10. But we have a concept of fast exponentiation where this can be decreased. Let me explain you how. So now let's see how many operations I am doing. So 3 raised to the power 10, as this is an even number, this can also be written as 9 raised to the power 5. And again, if I see a odd number, I can say that 9 multiplied by 9 raised to the power 4. Now again what I can do is 9 multiplied by 81 raised to the power 2. Again I can multiply 9 raised to the power 81 raised to the power 2 and we got the answer. How many operations I am doing? The number of operations I am doing is 1, 2, 3, 4. So instead of 10 operation, we needed only 4 operation. So if the number is very huge, then the gap is very much large if you ask me. Why? Because a number can be compressed in terms of odd and even log n number of times. So this is an idea. So if we are given raised to the power, so fast exponentiation is a method where in the naive method, if we do x raised to the power y, the time complexity would be big O of y. But if you use fast exponentiation, the time complexity would be log y because we are compressing the number by 2 at each times. 2 or just taking out that odd value. So that is why if you want to compute something x raised to the power y efficiently, you should know fast exponentiation. So here I am using fast exponentiation because I'm more like I like use of like I'm more used to fast exponentiation if you ask me. So now what I do is let me explain you the solution at this point. So now see what basically we do. This is, let's say, again we would see this thing. Let's say we have 5 raised to the power 7. So as 7 is an odd value, this is to check if it is an odd or not. So this is check odd or not. This is to check if it is odd or not. Basically, this is done because if a number is odd, its last bit would be 1. LSB, that is lowest significant bit, would be 1. If it is an even value, its lowest significant bit won't be 1. That is why we can simply do the AND operation with 1 and we can get the result. So now, if that value is odd, what we do is 5 multiplied by 5 raised to the power 6. We do this same thing we do. We take out that value of x and we multiply it to the result. Okay. And then after that, if the value is even, then we multiply. Let's say 5 raised to the power 6. It would be 25 raised to the power 3. And this is what anything done right shift divides it by 2. Anything done left shift multiplies it by 2. Remember it. So we want to divide it. We are doing the right shift of it. And then we are returning. And we are declaring mod again so that we don't lose track of m here. So mod of this and we get the answer. This is the solution. Let me just do a copy paste of the solution and send it to you. Comparatively, again, a simple question, but taking out the value is a thing. So now if you ask me that you can, if you solve up this problem and understand this problem, then questions like this, you can solve it in just a snap of your fingers. Done. So now please explain the 3 for 1 bit part. The 3 for 1 bit part. Like in one position, you can have 3 combinations. That is, if you just see up the formula, in one, like let me explain you here itself. What I meant to say is, in 1 bit position, I can have 3 possible combinations. That is, I can have 1 0 0 1 and 0 0. So all in total would contribute 3 to my solution. So if I need to fill 3 bits, that would be 3 multiplied by 3 multiplied by 3. That would be my solution. Okay, hope I am clear. Just give me a quick one if you have understood and there is no issues with the problem statement. And then we would be moving forward to the last problem. Bit manipulation questions always afraid me. So I have a one small, so I have a small thing to tell you. So if bit manipulation is a question which afraids you a lot, what you can do is bit manipulation, write code forces. And if you see, people have made notes on bit manipulation. Okay, people have really made notes of this. Okay, see, swap with XOR, checking if a number is power of 2, for clearing this. So what I did in my initial days is that I completed all the blocks out there on code forces and that helped me a lot. So if you see bit manipulation problems, see people have commented, see here is one bit manipulation tricks, helpful and concise for efficient coding. People are commenting this. See people have so where this is the idea, dividing it by 2, multiplying it by 2. I told you this. To check if the kth bit is set or not, to toggle the kth bit, to check if a number is power of 2 or not. People have, see, people have like bit manipulation tutorial, Trick 1, trick 2, trick 3. Read every one of them. Bit manipulation, which tricks do you use? People are talking about it. So if you are a person who is afraid of bit manipulation, I too was afraid of bit manipulation. And you can see up this also, bit manipulation by CP algorithms. I kind of have licked the whole website of this. I know each and every chapters where it is located. This is the best. This is the Bible of competitive programming. The competitive programmer's handbook, and this is the Bible of competitive programming. So you can read up this a lot. So do let me know if you think that is this was interesting for you. Just reply with a thank you if you thought that this was relevant for you as an help. Okay? Or you don't want me to blabber this all out. So now I would accept that the problem statement of this question was a bit hazy. The problem statement of this question was a bit hazier part. I would definitely tell you that. So now let us move forward and let me explain you this. The problem of statement was indeed hazy, but I would tell you a point where you can have the conclusion of what this question is trying to ask. So see, here in this question, if you ask me, Geek has n horses numbered from 0 to 1, and here you are told that you need, here it was told that horse A and horse B denotes that horse A is slower or faster than horse B. And you need to arrange the horses in order such that horse A is before horse B. Okay. So I need, so horse A, so here what was told? It was told that we are given A and B, and here A is faster. A is faster than B. It is told. Now you need to find the horses in order such that horse A is faster than horse B. So I need to keep A first, then I need to keep B. Okay. So then this, I found this line to be very confusing, to be honest. Now, this makes all the difference. Okay, basically you should know this, that this simple line makes a lot of difference out there. Okay. So if it was told that since there are multiple agreements, this sorry, since there are multiple arrangements, you can you can return any of them. Return any of them. One question can be of this nature, that if there are there could be multiple agreements, so return any of them. Like here, like if you go to CSES course schedule, it is told something like this here. CSES course schedule. If I go to this problem, here in this problem it is told that print an order, like print an order, you can print any valid order that includes all the courses. Here you can give out any ordering. Okay. And here you are told a little bit of different problem statement. The problem statement is that return the lexicographically smallest arrangement. And this is the point of difference. So now let me first talk about the problem statement. Let me talk about more about this problem solution, and I know what people were trying to do and why they were not able to fulfill it. Let me first tell you what this basically means. So whenever in any problem, just remember this. I think there is no intuition for this. Whenever you, whenever in any problem, you are given a set of ordering, and you need to give back a complete list which respects all ordering, which respects all ordering. Whenever you have this kind of problems, for example, let me show you two problems which tells us this. Like let's say here you are told that there are M requirements. Course A needs to be completed before course B, and it is told that you need to print an order in which you can complete all the courses. So again the same thing, set of ordering and return a complete list which respects all the ordering. Then there is one more problem which is asked a lot in interviews, that is alien dictionary. What is that? Here also you are told a set of, thanks to view this question you must subscribe to premium. ये काफी भेदभाव करते हैं नीट कोड वाले. Damn. So this is a problem which is asked a lot in companies, if you ask me. See, this is asked a lot. In the last 6 months, this has been asked a lot by top tier companies. In the last 6 to 1 month, in 1 to 2 years, many people have asked this. Here also, if you observe that here you are given a list of words. It is claimed that they are lexicographically by the rules of a language. And then you need to return a unique letters sorted in lexicographically. So here also, if you observe, this is concealed in. Here also, you are given an ordering and you need to produce the complete ordering. So whenever you are given a question like this, what you need to basically do is, the solution is nothing. I think there is no need of any intuition or like going on based of intuition. You need to remember this, to be honest. You should see nowhere but to think of something known as topological sorting. Problem like these can be solved using topological sorting. Now, in topological sorting, there are two methods to solve it. The very first method is by using a DFS. That is, in the last part of DFS, what is the code of DFS? Let me explain you though. Just after the DFS, when the DFS is complete, you insert that element, in the list, and then in the end, you reverse it and you get the ordering. Okay, and this works. Let me show you an implemented solution for this. How is this? Let me explain you the code itself. Just remember course schedule CACS. So now see, what I meant to say is that to find out so see, so there is one approach with DFS. And what is that approach? That is that after DFS, when you use the DFS approach, the DFS approach tells us that after DFS, insert the element in any data structure and then reverse, and then you would get the topological ordering. Okay, and this is true indeed. If I show you the code of course schedule, you would see this thing, like you would see a pattern in this coding part. So see this, like this code is the general code. If you observe this, visited of one and then visit all its neighbors. After everything is done, The only new line is that you are inserting. And this is after DFS insert the element and we are inserting it. And then in the end, we are just reversing it and we are printing it. And we get the topological ordering. So I think there is not much to explain that the first approach uses DFS. And in DFS, after the searching is complete, we insert that element and then we reverse the ordering. This is the first way we can solve up and get the topological ordering. And the very next way is to use Khan's algorithm. Find topological ordering using Khan's algorithm. Khan's algo by using Khan's algo. So we would talk about this, but let us first talk about that if this DFS is simple enough, then why can't we use this and submit it over in this question? Because what is the goal? The goal, the question needs a topological ordering, and we are getting that from the DFS. So why not use DFS and solve up this problem? This could have been the solution when the question had this. That is, the solution may have multiple or arrangement, you can return any of them. If the solution had this, then we could have used DFS and solved this problem. And we would have been very good with this and we would have got an AC. But this part of the question makes all the difference that we want lexicographically smallest arrangement. ये इकलौता बला है जो दिमाग खराब कर दे. Translating the same in English is, this is the nuisance maker in this problem. So if you observe that in a DFS, in a DFS, we don't have the control. We don't have the control which is the next element that would be visited. Which is the next element that would get visited. Why? Because this is done recursively and anyone can be assigned and kept there in the DFS. So we don't have a control over which element would get selected. So the ordering that we are getting might not be lexicographically smallest. Lexicographically smallest. And that is why this solution would give you a wrong answer. Because taking out the topological ordering using DFS does not guarantee a sorted result. Because see, the next value that we are visiting, it might be small, it might not be small. See, let's say that we are at a node of 5. And after 5, I can select 6 also and I can select 4 also. So if I want the lexicographically smallest ordering, then after 5, I should select 4 and then only I would get, see, let's do a very small topological, like let's do a very small topological sorting using DFS, using this approach. See, what we can do is, let's say we are told that after 5 complete, that 4 needs to be done before 5 and 6 needs to be done before 5. Okay. And then by that we find a directed graph from here. And if we do a DFS of it, it would be something like this, that we would call the DFS of 5, which would call the DFS of, let's say, the DFS of 4. And after that, it is calling, after the DFS of 4 is done, we would insert DFS of 4. Then it called DFS of 6. Then DFS of 6 was done. We got the topological ordering. Then after that, it is done. Now, if you observe, the topological ordering would be 5, 6, and 4. 5, 6, and 4. But if you observe, this is not the lexicographically smallest. Why? Because the lexicographically smallest one could have been 546, not 564. And both are correct. Here both are correct. 5 needs to be done before 4. What was told? 5 needs to be done before 6 and 5 needs to be done before 4. So both of this solution is respecting both the constraint, but by using DFS we don't have a control which is the next intermediate node that we are selecting. It might select 4 also, we might select 6 also. But we want it to select, if it had selected the next smallest element, that is after DFS of 5, the possible values are 4 and 6. If it had selected, if it had selected 4 after 5, then 4 was done. So then it would select 5 and then it would go to 6. Then it would call DFS of 6 and after that it would be 6 and then it would be 5. Then it could have been a true value. Okay. So we don't have a control what would be the next value that would get selected. So to have that control of the next value to be selected, why we want the minimum value to get selected. So to get the minimum value of that selection, we use Khan's algorithm to do it. Because in Khan's algorithm, we keep all the nodes in a queue data structure. Khan's algorithm is basically a BFS algorithm. And in BFS algorithm, we use a queue to store all the values. So I would urge you that you understand Khan's algorithm and then come to this video. But even if you don't know it, I would tell you that Khan's algorithm is an algorithm which is based on the BFS approach. And BFS uses a queue. So instead of this queue, if I replace this queue with a priority queue, then the work of queue would be done and we would select the next smallest or the greatest element. It would give me this next smallest element which would get visited because we take the first, what happens in a BFS? We take the first element from the queue and then visit it. So if we replace priority queue with queue, then it would give me the smallest element that needs to be visited next. And this is the control we needed. So we use the Khan's algorithm and instead of queue, we use priority queue to have that control of selecting the next smallest element. Okay. So basically this is the solution. I would urge you that you understand Khan's algorithm, DFS, BFS, and then come back to this video. So Khan's algorithm works on the idea that we select. So let me just copy it in my text editor. Do I have any issues up till now? Let me just see. So now see. So now what we do is we initially make a directed graph to do this. And instead of queue, we use a priority queue basically. Okay, we use a priority queue to solve of this. And whichever has the in degree of 0, we push it inside the queue. This is the what Khan's algorithm tells us. And rest is same. Rest, this is Khan's algorithm. The only difference is that we use instead of queue, we are using priority queue. And then we are returning the answer. See it up. If you have issues with understanding the code of this, make sure LURL, make sure. Okay, okay. Now I solved this question using topological sorted DFS in degree with Maxim, but why it will give wrong in some internal test case? It won't. Okay, don't use max heap. We should select the next smallest number so that we would get the we would get the topological small lexicographically. Lexicographically small topological sort was interesting. Yes. भैया दोनों में डिफरेंस क्या होता है? See, DFS क्या है? DFS is a recursive approach. Whenever it sees a person who is not visited, he would visit that person. DFS is that person. मतलब DFS कैसा है? He would go out, okay? If he finds a friend, if he finds a friend, he would simply take him home and then do party with him. But BFS is the person who would select the very first person who is standing in the queue. We have this control. So we want it to select the next smallest element. That is why whenever you need the lexicographically smallest or largest topological sorting, you should use Khan's algorithm to do it. And there are other ways in which you can do it. Okay. Other scenarios in which you should use Khan's algorithm. This is a proper use of Khan's algorithm. So whenever you need topological smallest or largest ordering, you should use Khan's algorithm. Whenever you need topological ordering, just topological ordering, you should use DFS. Okay. Anjum, okay. अगर adjacent list में descending order DFS कॉल करें तो that still would be problematic. Why I would tell you that? See, what you need to do is you need to you need to find out all the neighbors of the current node, then sort it and select the next smaller element and visit the next smaller element. You can do that using DFS also. But the problem is you need to find all the neighbors of that current node, store it somewhere, find the smallest node, neighboring node, and then visit it. You can do that also. Like, yes, this problem can be solved using this. This is a very good approach. See, you can do this also. See, in this question also, what you can do is here, just here, if you see any, like here what we are doing, we are seeing any value which is not visited and we are visiting it. So instead of doing this, first I find out all the non-visited nodes and find the minimum out of it, and then I visit it. That would also give me an AC, but that would give me a TLE too. Why? Because every time we are finding out the minimum at each step. Okay, so I would give you the hint again how Khan's algorithm should hit in your mind. That if I tell you to solve in this problem, what I should do? I should find all neighbors which are unvisited, and then I should select the minimum neighbor, the smallest neighbor, and then visit it. If you do this, you would solve up this problem. But see, if at any point of DSA, if you come to this conclusion that I need to find minimum at each step and the elements are changing, then you should definitely think of something known as priority queue. These are the small observation you find and then draw out an algorithm that if these are the requirements, I would use this. If these are the requirements, I would use that. If these are the requirements, I would use that. I told you that whenever you are given a set of ordering and a complete list which respects all the ordering, you should think of topological sorting. Then you find out that I need to find out the minimum at each step. Okay, I need to find out the minimum at each step. I need to find the minimum at each step and then return it. So I should think of priority queue. So if I'm thinking of priority queue, I have a Khan's algorithm which uses queue. So I can just replace queue instead of priority queue, and that would also solve this problem. Okay, that is why Khan's algorithm is more fitting over here. To be honest, if you are a person who is very good a problem solver, then you can optimize this DFS approach and implement priority queue over here also, and you can solve this problem. But that would be absolutely too much complex if you ask me. Do I make sense to you, Anshul Kumar Nikhara? I kind of forbidded you from asking again and again initially, but now I replied you explicitly. So do you understand me? Sir, in C++, priority queue is max heap by default, but in Java, priority queue is min heap by default. Yes, indeed. So in Java, you don't need to do anything explicitly, but in C++, you need to write the idea of it explicitly. Okay, so that's it from my side. No one has any queries. Can we use DFS topological? Yes, I showed you how you can use DFS topological for this question. So now if you are a person who is watching this stream till this very point, I tried my level best to explain all the solutions in a very concise manner and in a good so in with taking an example. So if you are a person who was with me till this point of the stream and you liked it and you think that this work should be justified, consider leaving a 1 in the comments so that the reach of this video could be increased and this work could be justified. And if you have the time, you can appreciate or criticize me in a constructive manner. But don't be abusive. I don't really like it. That's it from my side. I tried my level best to solve, like to tell you the pinpoints where you have been tripped. I think so. So I tried my level best. If you still think that there is an area for improvement, like I found some of the comments last time that I need to improve on my teaching thing. And if you think that way, you can tell me if there is some areas of improvement. You are improving watching me and I am improving teaching you. So we both have different goals and let's improve from each other. That's my thinking. So if you think that I need to improve, let me know. If you think that I need to be appreciated, let me know that too. If you're a person who just want this work to be justified, comment a one. That's it for today. This is me, Siddhartha Hazra, signing off. Thank you everyone. Have a nice weekend ahead.